NRB is a 49-year-old company, and it is the first company to manufacture needle roller bearing in India. And today, over 90% of the vehicle on Indian roads run on NRB bearing. And our vision is to make our presence across the world by the year 2020. Now coming with our problem resolution presentation, our project title is to eliminate needle missing bearing and establish mistake proofing in its functional test. We call it single piece flow robust 2A line. Our team, I am S.A. Khan. Three of us are present today, Mr. Ravi Shankar, Mr. Kumar. This was the complaint we received, one roller missing from the bearing. And see the picture, defective sample picture below, between the two yellow arrows, needle missing. This is our existing process flow. Station 1 is the bearing assembly. Station 2 to 5 are the functional testings. We identified three problem areas. The first one was the bearing assembly, where the misfitting of needle rollers was occurring. Second is the station 4, where there was no POCA for needle missing bearing. And then the batch production. You see the number of bins for collecting input and output. And we also revisited the design. This was our ppm value from January to July. The average is 352. Our analysis zeroed on needle flow mechanism as the cause of the defect. And the root cause was the needle guide design itself was such that the misorientation of the needles was not prevented. See the cages coming from the left, needle from the top, getting inserted, bearing assembled, and moving to the functional testing. But once the needle misorientation occurs, there is every chance that the very next bearing may remain partially unfilled, hence a case of needle missing bearing. In bearing assembly, needles reaches to the bearing in a needle guide. It has a rectangular cavity which doesn't prevent the needle to change its axis. Hence a vertical needle, the right picture. In a plain sight, it looks very simple. Needle moving along its axis, dropping laterally. But if you see the dynamics of the needle movement, the moment half its length crosses the plane, then it has a natural tendency to tilt due to law of gravity, and hence the needle becomes vertical. We took various trials with altering the needle guide design modification. One of it is like this. It is you can imagine as a two half cylinders face to face but staggered, which gives a zigzag motion. You can see the magnified geometry on the right. The successive needles, if we join the axis of these needles, they are not collinear. So hence a needle has to twist somewhere like this to become vertical in this. So we completely arrested the needle becoming vertical. But we could not go ahead with this from the productivity point of view. But after 800 numbers, we found that the edges were getting damaged. So we thought of, if we make the needle roll along its axis, then its axis will always remain parallel to the ground. So we designed an S-shaped guide where the needle flow is very smooth and needle rolls along its axis. So it will always remain horizontal to the axis will remain horizontal to the ground. So we completely eliminated the needle missing case. Bearing is designed to have some level of radial flow, and to increase the retention, the pocket side has to reduce. And for that to happen, the float will decrease, and vice versa. We studied the float and we found that there is some scope of optimization. After modification of punch and die, we reduced the pocket size by 30 micron, but without crossing the design limit of minimum float requirement. And we checked the push out load before and after for all the 16 needles of the bearing, and there is a substantial improvement, 78%, in the average force required to remove the needle from a bearing. And the result, the CPK improved. ppm from the last 4 months, average is 61 as compared to 352 earlier. Detection mechanism, it's a plain truth. It was a visual detection, prone to human error, cancelled oversight. And the analysis zeroed on manual inspection as the cause of the defect. And the root cause was needle, there was no POCA in the needle missing bearing. And our improvement idea was, if we could make a bearing rotate along its axis, and a photoelectric sensor detects the missing needle, and the major task was this has to be automatically loaded, unloaded, and automatically defect sample has to be solved. Back to single piece flow. The below process flow is the single piece flow, the same sequence of operation as above, but different configuration. Operations are automatic, operations are linked, and no input output collection in the bin, and even the manpower you see above 6 reduced to 1. This is our, before we play the actual video of our work, the concept of the line. Qualifying all tests, 5 cases, qualifying all tests, Lilian indexing, and then moving to the packing. Then rotation not free, checked, drops, then missing needle, similar, and then the ID retention, and similarly for the OD retention. So if you see that the end to end, it's a linear material flow. And let's see how we check the needle missing case. Defective sample will drop down, and when all the needles are intact, it will be unloaded in a V block and moves to the next operation. And the free rotation check. This is the most fundamental and important characteristic of a bearing, that its rolling element should rotate freely. And it is the single most deciding factor for performance and life of the engine. You see the top bearing rotating fast and below is rotating slow. And how we detect it? We are, through a rack and pinion mechanism, we apply a constant torque and we check the angular displacement in a unit time. Let's see how we do it, how we were doing earlier. Manual judgment, lot of skill required. It was a subjective inspection. And now, slow rotating bearing falls down, and OK bearing drops on this chute and then to the volume station. And retention. This is also very important from the point of view of handling of the bearing, whether it is our end or at the customer end or even in the transit moment. So needle should remain intact before it gets fitted into the vehicle. So this, if the needle, we apply a 3 kg load, and if the, on all the needles in the bearing, if the needle drops, get detected in the needle missing operation station and sorted out. This is the video of the entire our line, the 2 retention checking, then the coming to the needle miss checking, and then to the rotational check. In fact, the Mahindra rescue team has visited and acknowledged this development. So if the result, the process risk, you see the detection. Now it is visual to automatic control. It is the components, the defective components are automatically locked and doesn't prevent, it prevents from further processing. The substantial improvement in the reduction of the process risk potential. The benefits are compiled. The PPM reduced to 17%, no complaint from the last 6 months. Productivity increased by 3-fold, and WM inventory is 0 now, since it is a single piece flow. And the most important, the intangibles. Now it is subjected to objective inspection. Means human error scope is completely eliminated. These are the relevant documents, standardized, training imparted, the visual, the work instruction displayed on the machine. In conclusion, I would say, with a profound knowledge and working with the opinion of the population and seeking for the end-to-end solution, made our process robust and its measurement robust and yielded many proactive solutions. Hence, economical product and reliable process. Thank you.